Уважаемые участники, сейчас...
Dear participants, now we are going to listen to the presentation on Bruce Momjian on security in Postgres. So please welcome Bruce.
Thank you, everyone. It's, again, wonderful to be here. And we have a little more sun today, so the sun's coming in the windows, and it's a good day. I am here today to talk about securing Postgres. I have been studying this topic for quite a while, so I hope to be able to give you some ideas of how to use Postgres in a secure way. Again, I am Bruce Momjian. I am from the United States, Philadelphia to be exact, and I have been working on Postgres for 21 years. And I'm an employee of Enterprise DB, and have been working with the Russian developers for almost 2 decades. So we go back a long way, and we've had some very fun experiences together. I see some of you here that I've spent some very enjoyable time with. So let's get started. First, I wanted to talk a little bit in general about security. As you may know, security is a tremendously difficult topic because when you're writing a query, an SQL query, for example, you have a problem to solve, you just need the answer. So if you do the answer one way or another way, as long as you get the right answer in the right amount of, in an acceptable amount of time, that's kind of okay. Right? Nobody needs perfect. Okay, maybe you could have done the query a little differently, or you could have, made it a little faster. But in general, queries and running SQL has some ability to be imperfect. With security, it's the opposite. For proper security, you almost have to have everything right. Because, of course, there are people out in this world who will find whatever weakness you have and exploit it. So it's a funny field because so much of it has to be done perfectly. And actually what this illustrates, this dam, it's only good if every little spot can hold back the water. If there's any little hole, your dam is not working. And it's very similar with security. So what I'm going to talk about today is general ways to secure Postgres from external attack, meaning things that come from untrusted users who are not part of the Postgres ecosystem. We're going to talk about the default permissions in Postgres. We're going to talk about how to handle passwords and authentication theft. We'll talk about things like snooping and spoofing. And finally, we'll talk about some administrative issues related to security. What we are not going to cover, and what I could cover in another talk, are issues related to security for authorized users. This is basically an attack from inside. This is not what I'm going to be covering. Things like database permissions, SQL injection, and so forth are topics that are unfortunately not part of this talk because of time constraints. So let's talk about authentication security. Of course, many of you may have dealt with this before, but it's always good to kind of go over it again. This is the authentication file that is shipped by default with the Postgres source install. It's called PGHBA.Conf. HBA stands for host-based authentication. The name was developed over 20 years ago, and many people don't know what it actually means. But effectively, PGHBA.conf allows you to specify who can get in to a certain machine. And again, this is your default install. Again, for source installs, if you're using a package manager like RPMs, Debian packages, FreeBSD packages, or Windows, you are going to have different defaults here. In fact, down at the bottom, it indicates that when you run initdb, you can actually use a capital A option to change the defaults for PGHBA when you install it. So for most secure environments, we're going to suggest that when you run initdb, you actually use a different default for these permissions. The reason it's set to trust is just because we assume you're a developer, we assume you're just testing Postgres, but when you're going to be installing it in production, you are going to be using a different default here. Okay. Another issue that is related to Postgres is the ability to send passwords back and forth across the network. This is something you may not have thought of, or maybe it's something you thought of and forgot about. But when you make a connection from the client to the server, all the information is going across some type of network. And in almost every case, that network is not secure, because almost by definition, all of the networks like Ethernet or the Wi-Fi networks that we use are in some sense shared spaces. So as the packets are being sent back and forth, there is some ability for other people who aren't part of that connection to see the data that's going back and forth, okay? So here we have an example of the way Postgres would do a typical password prompt. I don't recommend this, but I'm just showing it to you for illustration so you can see exactly what's going on here. Effectively at the top, and unfortunately I can't use a laser pointer because I don't think it, I'm pretty sure they don't show up on this kind of a screen, but effectively what happens is the database says I want to connect, and the client says I want to connect, the database says I need a password, and then the password just gets sent unencrypted over the network. Now, as you can see on the right here, we do encrypt the password when it's stored in the database, okay? But again, that whole arrows going back and forth is not really secure. And that's probably a bad thing, because once somebody gets the password, obviously they can reuse it. Okay. So Postgres has a second method for doing authentication. It's called MD5. That's an actually a superseded method I'll talk to you about in a minute. But effectively, what happens with MD5 is that a connection request is made from the client, and the server sends back two things, okay? It sends back a request for a password, but it also sends a random number. And in this case, the random number is called a salt. It's just a random, nonce, if you're used to that term. So it's just a random number that gets sent back, sent to the client. As you can see on the bottom set of arrows, what the client will do is it will take the username, the password and the username, combine them together. It will MD encrypt that, and then it will take the salt, the random number that was sent from the server, and it will MD5 that again with the result of the previous MD5, and it will send that over to the server. And the server effectively will then use the same salt, run the same process, and compare to see if the output that it got from the client is the same as the output that it computed. And if they match, it knows the client understands this password. Now, you may be saying, oh, gee, the MD5, that's not secure. Well, it kind of is in this case, because we're not worried about collisions. We're not worried about have somebody knowing the original hash I realize there are some cases where MD5 is not secure, but in this case, it's really not an issue. However, in work to expand Postgres and to make it more secure going forward, Postgres 10 added the ability to do scram. I'm not sure how many of you have heard of the term scram, but scram is a more secure method of hashing passwords. So effectively, in Postgres 10 now, you have a scram option as well as an MD5 option. The reason I don't have a new slide on this is that it's really the same as MD5. In other words, the process you're going through here to send the password across with the salt and then back again is actually the same with scram, and it's the same with MD5. Okay? Now, in Postgres 11, this gets much more interesting because we then have the ability to do what's called channel binding. And again, I'm getting a little ahead of myself because this is not in a released version of Postgres. It won't be out until probably the September or October of this year. But starting in September or October, you'll have a much more sophisticated way of doing password setups than you will now. But again, it's not done yet, so I'm not ready to kind of give you a slide on it, but be looking for that. If you're running Postgres 10, you should probably switch over to Scram. It's a better solution than MD5, and you'll be ready once you switch to Scram when it comes in Postgres 11. You'll have the ability to use the channel binding capability, which is really kind of interesting, and I'll talk about it a little later. So I'm kind of in a weird position where I know the feature's coming, but it's not released yet, so do you show people or not? But let's just keep going and know that even better stuff is on its way. Okay. So you might say, okay, what is this salt thing for? Why are we sending a random number to the client? Like, it's random. How can it mean anything? Okay. The reason we use the random number with MD5 and the reason we use the random number with Scram is to prevent something called a replay attack. So as you may imagine, when the client sends its password across and with MD5 encryption, you can't see the password, right? Because it's hashed, okay? But what you don't want is you don't want somebody to take the hash and just replay it. For example, if I look at the top example and I send a salt, we'll call it salt 0, random number 0, and I send it to the client encrypts everything with salt 0, okay? What's to prevent another client from seeing that hash come across and just saying, oh, I'm just going to connect as that same user, and I'll just use the hash I just saw, right? They don't need to know the password if you just hashed it. So in the example on the bottom, what happens is a bad user tries to connect, in this case called malicious, okay? They try to connect, but in this case, the second connection gets a different random number. And because it gets a different random number, the server is expecting a different hash to come back than the first user, okay? So if that malicious user tries to send a password back using salt 0, which is the salt it saw from the previous connection, it won't work. It won't work because the salt 1 and the salt 0 are different numbers. They're going to generate different hashes. The only way the user at the bottom can generate the proper hash is for them to know the password, okay? And this is the method that we've used since we've had MD5, which is probably 18 years, 19 years, to prevent the replay of packets, the replay of a password packet that may be hashed, but if it doesn't have some sort of random component it can be reused over and over again. And that's why the salt is there. The scram method, which was added in Postgres 10, actually does the exact same thing. The only difference is the salt's a little bigger. So I believe in, as you can see here at the bottom, when we originally designed the salt 4 years ago, or 19 years ago, we used a 4-byte integer. And those of you who are good in statistics will know that you will replay that random, if you randomly choose numbers in that 4-byte address space, you will replay that salt. You'll have a 50% chance of replaying that salt after 16,000 connections. So what a malicious user could do is to continue trying to connect over and over again until they get salt 0 to happen, until they get another request from the server that uses salt 0. And of course, at that point, they're able to replay the packet they saw before, and they can get into your database. So this is probably the biggest win in Postgres 10 for using Scram, because Scram prevents, I think Scram uses I think it's a 16-byte random number, so it's big, 128-bit, I think, random number. So there's not really any likelihood of a replay of a random number being chosen in any reasonable amount of time. And that's probably the biggest win for the Scram method in Postgres 10. Okay. Another way that, and this is very, very typical, another way you can have attacks are people who choose weak passwords, people who reuse old passwords, brute force password attacks. Postgres really doesn't have a built-in way of securing these type of things. Postgres has a tendency to rely on external tools like LDAP or PAM or SSPI or GSSPI on Windows to do password management. So if you need this type of password management, you're probably better off using one of these external methods that's designed to handle passwords. I'm not saying passwords are wrong, but the ability to sort of manage passwords in a sophisticated sense really never took off in Postgres. Most large enterprises are probably already using things like LDAP or SSPI within their organizations, and Postgres just plugs in very seamlessly to that. And that's usually what you see people using. Okay. Another issue, you might think you only have to worry about the passwords going back and forth. But in fact, the passwords are just a small part of a full secure implementation of Postgres, because no matter how well we do the passwords, okay, potentially all of your data is going back and forth across this network, right? So we might secure the password, but if you can see all the employees' salaries when somebody does a select, that's kind of a problem. You're basically just watching all data coming across that anyone has requested. In addition, if somebody changes the password remotely, that also could be passed across the wire. So again, not something that, that maybe you want to do. The idea of the password is just one part of security. Another part is securing that communication after the password to make sure that nobody can see what's going on. So the normal approach here, if you're trying to secure a communication channel for Postgres, is to use SSL, or more technically TLS, for those of you who are kind of up on the current security protocols. But TLS or SSL is the way that you would basically encrypt a channel, a communication channel between a client and server to make sure that nobody can see any of the data going back and forth. And it does this very well. It's usually very easy to set up. Performance is minimal. The only performance impact you normally see with SSL is that the start of a session is going to be slightly slower because you have to establish a secure connection. You have to use some sort of protocol to make sure that the two ends have a secret that they can share to encrypt their data, and that initial connection between the client and the server can take a little bit of time. So if you're implementing SSL, of course there are some good reasons to use it. Just be aware that there is going to be normally a startup penalty for that. And again, you would normally see it if you have, it would be dramatic if you had very short-lived connections. But if a normal connection, the startup is fairly minor. So you might think, okay, great, I'm using MD5 for my passwords. I'm using SSL to secure my connection across. I'm done. Okay, I'm good. I'm secure. Not really. Not really, because if you take a look at this person, this is somebody who's pretending to be someone else, or someone who is hiding their identity. Okay, and a lot of sites that don't have full-time security people believe that once they've used the MD5 and once they've used SSL, their security job is done. But in fact, that's not sufficient for Postgres. It's certainly not sufficient for any secure website that you visit today. There is a third component that's really required to do proper security. So let's take a look at exactly what that is. The first one is a little odd. This is kind of an interesting attack, but I wanted to mention it. Let's suppose that your server is not running. So for some reason you have it down for maintenance, or for whatever reason you're not running your current server. Maybe could be any reason. Okay, and while your database server is down, your computer's still running. It's just the database server is down. What if a client tries to connect to Postgres? Well, you would think, okay, server's not running, therefore it's not going to connect. It's going to fail. And in most cases, that's true. But what if a malicious user, a fake user, starts a Postgres server on the same port number as your database? In this case, the port number is maybe 5432, which is the default. So they start a fake server. Your server's not running. 5432 is not a protected port number, so you don't have to be root to use the port number. So they just start a server. And you connect and you say, hi, I want to connect to your database. And the fake server says, sure, give me your password. But don't MD5 it, just give it to me. And your client says, okay, here's the password. Okay? And the fake server records the password and shuts down. Then later, the main server comes back up, you start up your server, and that fake server now knows somebody's password and they can connect. Okay? So just be aware that that is a possible problem, that somebody could start a fake server on your same server while it's down and effectively grab a whole bunch of passwords and use them later. Another problem, you might think, okay, yeah, so basically they're gonna reuse the password. So here's the system kind of creating the password. Okay. I'm sorry, hold on. Yeah. So So you might say, okay, well, I don't have that problem, and my server doesn't go down, and I'm good. I'm good. But what if you have a sophisticated network? What if you've got a router, you've got your clients on one part of the network, and then you've got some network in the middle, right? And then you've got a bridge, and then you've got the database servers over here, okay? So you might say, okay, my database server is not going to go down on this network, and over on this network, I have my clients, and everything's going to be good, okay? But I'm not sure if you're aware of how networking works, but effectively anyone can make an IP address. So somebody could be sitting on the network with the client and say, I'm just going to make my laptop have the same IP address as the database server that's 2 networks away. And you're like, oh, that's not going to work too well, because the person, okay, then they're going to connect to it, but then when they try and connect, they're going to get failure because that's not the database server. Well, what if this sophisticated laptop uses the IP address of the real database and it just funnels all the traffic through? So it's basically connecting from one network to another computer on the same network, and that one is actually sophisticated, sending its packets to the real database server and then sending them back again and then sending them to the client who requested it, right? And it's grabbing the password as it goes by, and of course all the queries are going through. This is bad, and of course it's really a potential problem. Okay. Now you might say, okay, I'm gonna fix that. Okay, I'm gonna use SSL, right? So I'm not gonna do like normal networking. I'm gonna use SSL. Okay, but the fact is that with Postgres, the default mode for client for the client is to prefer SSL. And I know this is a very odd default. We've had huge arguments about it. But if in the Postgres client you don't force SSL, if you don't have a connection string that says, I require SSL, if you just leave it default, which is prefer, effectively you could connect from the client to the fake server, and the fake server said, I don't want to do SSL. The client says, okay, we'll just do it without SSL. Okay? And now you're basically sending everything back and forth that's not using SSL. Okay. But then you say, oh no, I'm going to fix that. I'm going to change my libpq connection string to require SSL. Okay? And you set require on there. And you know what the fake server does? Fake server says, sure, I'll do SSL. Fake server starts up SSL. And back and forth, as you can see here on the left, it's communicating to that fake server in SSL. Nobody can read the traffic between that client and that fake server, right? We're secure. Well, yeah, I guess, except once it gets on the fake server, then the bad person knows everything I've sent them. It sees all the queries, it sees all the passwords, and all the results as well. And as you can see on the right-hand side, it communicates either via SSL or not via SSL to the real database server, okay? So my point here is that SSL itself is really not helping us in terms of preventing somebody from impersonating the real server, okay? And that's why I said earlier, if you think you're using password and SSL and everything's secure, not really, because this type of interruption between the client and the server is a serious problem. And it's a serious problem, but it's a solved problem, okay? Believe it or not, Postgres is not the first system to need a secure environment. Obviously, for all of you who are doing online banking and buying things from Yandex and Yandex Taxi or whatever online transactions you're doing, you're already using a much more secure method than just SSL. And that method, fortunately, is part of Postgres. And that is the concept of certificates. You've probably heard of certificates before. You might not have actually had to use them. If you are in a browser on a secure website and you look up at the URL bar that has the website, right next to it you'll see like a lock or something in green, usually at the top. And if you click on that, it'll show you the certificate for that website, okay? And if you click on it more, it'll actually show you the certificate and who signed it and a whole lot of sophisticated information about why you can be sure that you're talking to Mail.ru, or you're sure you're talking to Yandex, or you're sure you're talking to any of the other websites that have to prove that they are who they say they are, okay? So with Postgres, the only real secure solution, which is unfortunately not the default, is to specify in your client a requirement called Verify CA. It says right up at the top in the title. And what Verify CA does is it guarantees that a root certificate that you can see displayed here in blue on the client, okay, on the left, it requires the database server to supply a certificate that is signed by, cryptographically signed by, the root certificate that exists on the client, okay? That is the only way that Yandex proves you're really on a Yandex server, and that's the only way you can prove you're actually talking to the Postgres server, okay? And if you take a look at the root certificate on the left, on the client, and you take a look at the server certificate on the right, which is on the database server, you will notice the fake server does not have a certificate because it's fake, right? So effectively, while MD5 and Scram allow you to prevent people from seeing passwords, and while SSL gives us a secure communication channel, it is only certificates that allow us to guarantee that the person on the other end is someone who I should be sending queries to, is someone who I should be sending passwords to, is someone that I can trust to send information to. This is the way websites work, and unfortunately the only secure way you can make sure Postgres works, okay? In this particular example, if the client sets Verify CA in the client connection string, and the fake server tries to pretend it's the real server, unless it has access to a certificate signed by the certificate authority that's in that root, in the client there, you're not going to connect, okay? Again, same method that every browser uses, Postgres can use it as well. The good news, well, the bad news is that this was not perfectly documented. We documented it very well, but there was some sophistication with intermediate certificates, for those people who are familiar with that, that was a little unclear in our documentation. Released, let's see, in 2 days, we will release the next minor version of Postgres, and the next minor version of Postgres will have improved documentation on how to set up SSL certificates with Postgres. It'll include better examples. It'll actually show you, here's an example of how to create the root certificate, here's an example of how to create an intermediate certificate, and here's an example of how to create the server certificate. So again, Thursday, there will be a new minor release of Postgres, and all minor versions to be released on that day will include updated documentation on how to set this up. So if you're curious, wait a day or two. Check out the docs. It took me a long time to write them because I didn't understand them either. The way certificates work, particularly intermediate certificates, is a little complicated, and it's not well documented. At least it wasn't until now. So I'm hopeful that this will encourage people to use SSL certificates. Okay. Another method, in fact, that eliminates certificates entirely is something called SSL Certificate Authentication. So it is actually possible for you to bypass passwords completely. No passwords anymore, okay? What you can actually do is to place a certificate on the client that has the username inside the certificate. And you send that certificate with your username to the server, and the server will then authenticate that you are who you say you are. So I would recommend those people who are doing certificates to consider using certificate authentication. It's a little different. Again, the Postgres docs are very clear about how to set it up, and it does allow you to effectively bypass. You don't have to type the password, nothing. Just have their certificate file, send that to the client, and the client can verify that you are who you say you are. So I think that's a great option. So I've kind of talked about password security, communication security, and finally identity verification. Probably three really important things about security. But I wanted to talk about some other areas that don't get covered as much. And again, we have to have a secure environment in every way to be effective. So the first one is the idea of disk volume encryption. Now, some of you may not find this very useful, but some of you may. What this involves is the ability to store encrypted data on the platters. This is normally done as part of the operating system. I know, I believe ZFS has an encryption capability as well as a compression capability. I think Red Hat might have a solution for this. A couple of different vendors have built-in solutions for encryption. And what this is designed to do is really to prevent anyone from reading the data if the media is stolen. So if the disk drive is stolen, if the computer is stolen, the idea would be that even if you have the physical media, you can't kind of take it away. Okay. Another aspect I wanted to talk about before we finish and take questions, of course, is you might be worried about encryption of your data that you're using, but also make sure you're being safe about your backups, because your backup media has all your data too, right? So don't only worry about the media you're using every day. Be aware of the media that you're backing up to and where that media is going. A funny story, I used to be a consultant in law firms, and I'm in the server room one day, and in the corner of the room there's a box, and it's got a whole bunch of tapes in it. And I say, Herb, I said, that looks terrible. Why do we have a box of tapes sitting in the server room? And he's like, well, those are our backups. I'm like, yeah, I know what they are. Like, why are they just sitting there? Why are they here? He's like, well, he said, if somebody picks up a tape and walks out of the law firm, they've got all our data. He said, we want to keep it in a secure location, and this is the place for it. And I'm like, you're kind of right. That's really something I hadn't thought about. But the concept of somebody taking backup media, walking out of the building, is one of those aspects of security that you have to be aware of. Another area that is often interesting for security is encryption not of the entire database, but of individual columns. This is an example of encryption using just encrypting, say, a credit card number and having some type of hash or MD5 or a decryptable option like AES that allows you to either hash it or encrypt it and decrypt it at will. This is, of course, very possible. Let me just add that I've really only talked about pretty basic stuff for encryption here. My website, which actually you're going to see at the end of the presentation, has 4 new security talks that I wrote in the past month. One of them is about SSL, one of them is about security basics, and 2 of them are about hardware hardware cryptographic devices. So like cryptographic hardware, if you've ever seen like a YubiKey or USB type of encryption hardware, feel free to take a look at that. Much more sophisticated, but it goes into a lot of the mathematics behind SSL and TLS. It talks about elliptic curves. It talks about how Postgres does verification of certificates. It talks about how you can use hardware cryptographic hardware with Postgres. So feel free to take a look at that. In fact, to be more specific, one of the problems you have with cryptography is where do you store the key, right? Do you store the key on the database server? But then if somebody steals the database server, you have the key with it, right? Do you store it in some type of cryptographic server in the middle? Or do you store the key on the client and then the client encrypts and decrypts and the server doesn't have it? Again, these are really hard questions to answer, but I mean, I could have a whole talk just about that. Where if you're doing that type of encryption, where do you put the key? You put it in the middle, in a cryptographic store somewhere? Do you put it on the server? Do you put it on the client? It's kind of hard to know, okay? In fact, one of the nice things about a hardware token is that you can take the hardware token out of the computer. So there's actually some value to being able to say, hi, I'm going to put my token in, I'm going to encrypt and decrypt data, and as soon as I take my token out, there's no more decryption happening. And one of the nice things about hardware cryptography is that you cannot get, the key cannot be copied off of the hardware device. There's no way to physically get the private key off of the hardware device. And that has a lot of benefits. So that when you put your key in, you know that the key can't be copied by someone. And I think that's, again, my hardware cryptography talk, the cryptographic hardware talk has that. In fact, down here on the bottom left, that is the URL where you can find those 4 security talks that I've written. It's over 290, I think it's 294 slides, so it's a lot. I would have loved to give the talks here, but we'd have to allot probably 6 hours, so I don't think we want to do that. But I have a couple of minutes, and I wanted to take some questions from the audience, and I'll be glad to repeat the question. So who has the first question?
I was just wondering if you could comment on the issues that can come up if you're using, say, LDAP authentication for password management, and you don't encrypt your connection with SSL, or you're using PAM or something else where the password, where Postgres has to know the external password.
Yeah, that's a great point. I don't think I have to repeat the password the question because everyone heard it. So if you're using an external password manager, that's exactly what's going to happen. The password is going to go effectively clear text, right, across the network to the server. The server's then going to make a connection to the LDAP server with that password, right? And it's going to come back saying yes or no. And in that environment, you're effectively going to have to use SSL between both segments, and you're going to have to use certificates within both segments. And in any case that breaks down, you're going to have you're going to have a problem. The only other way of going at it is if you use like SSPI, effectively the client gets a token and it passes the token to the server. So you have a little SSPI versus LDAP. SSPI is a little less information passing around because you're sending your tokens instead of literal passwords across. But effectively, you have the same problem that you have to have a secure channel between the two. Yeah.
Hello, thank you for your speech. I want to ask you a question. A certificate can be stalled by a middle person. How can it will be solved?
Okay. So the question would be, if someone's in the middle and they receive the certificate, could they just pass that certificate forward to the real server and back again? Is really what you're saying, I think.
Yes.
Right. And that's a great question. A lot of people ask that. So the certificates themselves are public. So you can download the certificate from my website right now and look at it, right? And the same thing with Postgres. You can, all the certificates contain are the name of the website or the name of the user and then a public key. The certificate is only useful in communication when you not only have the certificate, but you have the private key that matches the certificate. This is often many people are confused by that. So having the certificate itself does not give me access, does not prove my identity. It's having the certificate and also being able to answer a question that's encrypted with the public key and decrypt it with the private key and answer back. And the way the TLS and SSL use this is that effectively they take some information about the SSL packet, the protocol between the two ends, they encrypt that information, send it to the one end, and it has to decrypt it. You can't pass that on because every SSL connection has a different set of secrets. So they end up, very similar to channel binding, they end up being bound to the SSL secret in the network itself. And the network between the real server and the fake server cannot be reproduced, and it will never be the same as the network settings, the secret between the fake server and the client, and that's what prevents that from ever working. But that, I had to answer that question I had a security expert didn't understand that last week, so it's a very common question.
Yes, and one more question. How much slower with column encryptions? If I use column encryption, how much slower is Postgres be?
Right, so it depends how you do it. Some people will have an encryption. Well, it depends whether you use symmetric encryption or public key encryption. So if you use public key encryption, you are going to take an impact every time because the mathematics behind public key is very sophisticated. Most people don't do that. They take a symmetric encryption and they use the public key to encrypt the symmetric key. So it's like a double encryption. It's the encryption key, symmetric, and then they put the public, they encrypt that. If you do that way, most hardware has, most servers have CPU acceleration for AES, so the impact is minimal for symmetric encryption because you're using symmetric encryption all the time. When you're on a website, all that is symmetrically encrypted every time you send something. So you won't see an impact with that. It's normally the public key, private key part that you see impact.
Thank you.
Sure.
Hello. What if someone will try to brute force the password of the Postgres instance, and does Postgres have some mechanisms to protect self-instance from distributed password brute forcing using some dictionaries of
Right. So the
well-known
answer from this slide is that it does not. There really is no built-in mechanism, and that's why we normally tell people to use LDAP or to actually use certificate authentication. Because as you've seen from this talk, you kind of have to use certificates anyway, so you might as well just use certificates for authentication as well. Get rid of passwords completely. You can't really brute force a certificate because the numbers are just so big. The concept of passwords, and I go into it in some of my other talks, but passwords are really, you're just seeing them less and less. It works fine on like a website that has a whole mechanism for detecting fraudulent activity, like Google or whatever. Yandex, I'm sure, has a whole team that's monitoring for this. But unless you have a whole team that's monitoring for this, then for small sites, it's just probably better to, because the password has to be easy to remember and typable, but also not brute forceable. They're almost mutually exclusive. You know, if I require the password to be 50 digits, well, hey, we're good, but nobody's gonna be able to type it. So that's why I think the certificate authentication is really powerful.
Hi. I have a question about certificate authentication. The client certificate have to be issued with the same issue that server certificate or not?
Okay, so technically no. Okay, so are you asking whether you can have intermediate certificates in the hierarchy?
Yes.
Yes. Oh, absolutely you can. And it wasn't clearly documented until Thursday. Okay? So Thursday, much clearer about where to put the intermediate certificates and how to set up the configuration. Previously, we didn't have good documentation on this, but you do not, in a normal instance, you're going to have a root certificate. That root certificate is going to create one or two intermediate certificates, and then the root certificate is going to be stored offline, right? And then your intermediate certificates are going to sign your servers and your clients. Yeah, that's the way you should be doing it.
Thank you.
Sure. I think we're out of time. Is that right?
Hello, I have a question about encrypted data transfer.
I guess we're
so,
not. Okay, yeah. Yes.
I have a question about encrypted data transfer. So if I turn this feature on, how it's gonna affect the performance?
Yeah, so if you enable SSL, most clients and servers have CPU acceleration for SSL. Make sure that it's enabled. If you look at my presentations, it'll show you how to see if your CPU is enabled for AES encryption, AES acceleration. Again, the impact is normally on the startup. The startup is a little slower. Other than that, you'll never notice a difference. So just think of the startup as being a little slower, and everything else you'll never notice. Yeah.
And can I ask you?
Yeah.
And what's up pulling with certificates?
I'm sorry?
What's about pulling with certificates? So the main problem is that every user should have its own key, yes?
Right.
Its own certificate.
Right.
So many users, they all should have their own certificates, and that's why. What's about pulling? I can't use it, yes?
I'm sorry, you're saying the word poll, P-O-L-L?
Pulling
Pulling
yes.
certificates.
PG pool, something like this.
Oh, I'm sorry. Thank you. Okay. Yes. That is a huge problem. You cannot pass certificate authentication through a pooler, and the reason is because of what I had said to this gentleman, that the secret that has to be validated with the private key is bound to the SSL parameters, and you're going to have different SSL parameters from there. And in fact, it's almost to the point where we're thinking of putting a pooler inside of Postgres, and one of the advantages of that is that we can do proper authentication. because there's no way to do proper authentication. We can't even do scram authentication between client and server with a pooler in the middle. It's a problem. It's a problem we have to fix. So, am I out of time?
Плюс у меня тоже есть вопрос, но я не смогу на ваш.
I also have a question, but I wouldn't be able to ask it in English, so can you take the headset?
Attacks are insiders.
Apologize, because I should have brought my translator here, so I could have heard you, so it's my fault. I forgot to bring my translation device with me. As I said on this slide, I haven't talked about internal attacks. That I'll probably have to write that new presentation to sort of do, you're right, this is a separate topic and something that's going to be a whole new presentation, sorry. So, I think we're out of time, so thank you very much.
Thank you, Bruce, for the interesting talk.